Today, lesson 13b. We started the year with integers. Then we went on to combining like terms, and then solving equations, and then real world or word problems that involved integers. Then we did exactly the same thing with positive and negative decimals. Now today, we start that process with multiplying and dividing rational numbers. In other words, multiplying and dividing positive and negative fractions. If you know how to multiply and divide positive fractions, and you know how to multiply and divide integers, it's just putting those two pieces together. So today, you'll be able to find the product and quotient of fractions and state fraction problems and answers correctly. We've done enough with positive numbers or positive fractions that this should not be a huge deal. All right, so let's get started. A little bit of background knowledge. One of the things that I've tried to fix since the beginning of the year, fix things that you learned in the 6th grade. A lot of you like to just multiply straight across. Well, I'm telling you right now, that's not a good strategy. And the reason is because as the numbers get bigger, it makes it harder to reduce, and it takes a lot longer. So we want to get out of multiplying fractions this way. We want to move away from doing it that way. We want to utilize cross-canceling, and we've talked about this many different times. And cross-canceling is basically where we are reducing before we multiply, because it's a lot easier to deal with it. So this is really the way that we want to do a problem like this. In other words, 5 goes into 5 once and 10 twice. 3 goes into 6 twice and 9 3 times. Now multiply straight across. It's just much easier to deal with the smaller numbers by cross-canceling. Okay. Let's go ahead and start at number 1. So we're going to practice first with a positive number problem, and then we'll go into some problems with negative fractions. Once again, we don't really want to multiply straight across. I mean, this problem actually has fairly small numbers, but even this one, if you multiplied straight across, it would take you a while to figure out how far it reduces. What you should have done is you should have noticed 3 goes into 3 once, 27 9 times, and then 8 goes into 8 once, and 16 twice. Now when you multiply straight across, you can see that we end up with a product of 2/9. Let's go to number 2. Remember, when we have whole numbers or mixed numbers, we want to turn them into improper fractions before we do anything. How are we going to write negative 2? Yes? Negative 2 over 1. And then obviously we're going to turn 3 1/6 into 19 over 6. And then it's really the same sort of thing. Now, here's my advice. So that you don't lose the signs, look at the original problem. I know some of you are already working on it. Stop what you're doing, please. Look at the original problem. Will this have a product that is positive or negative? Negative. Negative, because the signs are different. Those same rules apply no matter whether we're talking about integers, decimals, or fractions. All right, go ahead and finish it off, please. But look, we've done this a lot lately where I've sort of told you, based upon an answer that you give me, whether it makes sense or not. When I look at number 2, and if I'm estimating, when I'm estimating with decimals, I sort of, in my mind, I cross out the decimal. Or with fractions, I cross out the extra fractions. What's negative 2 times 3?
Negative 6.
Negative 6. That means the answer has to be somewhere around negative 6. Maybe negative 6 and something, or negative 7 and something. So the answer that was given to me makes sense. The answer of negative 6 1/3 makes sense to me. So now let me uncover that 3 1/6. Remember, you need to turn whole numbers or mixed numbers into improper fractions before you can do all of the cross-dividing thing. And in number 2, the only thing we can do is we can cross-divide with the negative 2 and the 6, and don't forget that that is a negative 2. So 2 goes into negative 2, negative 1 time, and 6 3 times. I can't do anything the other diagonal, so now I multiply straight across, and now I have to turn that back into a mixed number. Obviously, the answer will be negative, and so if you can't do that in your head, see how many times 3 goes into 19, which is 6 times. with a remainder of 1, and it's always easier to write our answers as a mixed number. So the product is -6 1/3. All right, here's what I want you to do. I want you to do number 3 and number 4, and then we're going to check both of those with our shoulder partner. Before I ask somebody to the answer for number 3, could somebody please raise your hand and tell me why the answer to number 3 has to be positive? What is the reasoning there? Yes? Well, let's be careful with that. 2 negatives make a positive. We have to be a little more clear than that.
I know. If you multiply 2 negatives, it makes a positive.
There we go. That's a little better. Because we are finding the product. We are multiplying 2 numbers together. So, in that diagonal, -7 goes into -7 once, or -1 times. It doesn't matter. And then 21 -3 times. Nothing goes into both 5 and 8 except 1, so we can't do anything there. Now, if you multiply straight across, you have -5 over -24. But a negative over a negative is a positive. Therefore, the product is 5/24. Number 4, obviously, we're multiplying 2 positive numbers. Or another way of looking at that is that the signs are the same. Therefore, the product has to be positive. Convert them both to improper fractions. We can do some cross-dividing that way. 7 goes into 7 once and 14 twice. We can cross-divide that way. 3 goes into 3 once and 15 5 times. Multiply straight across. We have an improper fraction here, so now we have to convert that to a mixed number, which is 2 1/2. So the product in number 4 is 2 1/2. All right, so now let's go to dividing. And, of course, when we are dividing fractions, when we divide, we have to make sure that we flip the second fraction over. That's called the reciprocal. So in other words, we have to turn it into a multiplication problem. So 4/5 divided by 2/3 turns into, as a multiplication problem, 4/5 times 3/2. Remember, it is only the second fraction that you are flipping, not the first one. The first one stays exactly the same. From there, it's a multiplication problem, and you should do some cross-reducing before you multiply straight across. All right, so let's go to number 5. Everybody try number 5. So in number 5, it turns into, as a multiplication problem, 3/8 times 2/1. You can cross-reduce with the 2 and the 8. 2 goes into 8 4 times. 2 goes into 2 once. Multiply straight across. It is proper. And here's what I want you to do. I want you to now finish 6 through 10. Do all of them, and then we will check with our shoulder partner. All right, number 6. I can tell just by looking at the original problem that the quotient should be negative because I have a positive divided by a negative. And in my opinion, you should deal with that before you even start the process of doing anything else. It's always a shame when you miss a product or a quotient just because of a sign. You should not be missing the sign. So, I turn it into a multiplication problem. I cross-divide where I can. I end up with -7/5, which is improper, but that as a mixed number is -1 2/5. Number 7. Once again, turn it into a multiplication problem. Cross-divide where you can. Multiply straight across. Once again, this is improper, but as a mixed number, it is 1 1/6. Number 8. Turn it into a multiplication problem. Do some cross-dividing where you can. Multiply straight across. This fraction is proper. So number 8, the quotient is 2/3. Number 9, we need to turn them both into improper fractions first. Then turn that into a multiplication problem. And then can't do any cross-dividing, but we should end up with a quotient of -1 3/7. And then the last problem, turn them both into improper fractions. Turn it into a multiplication problem. Cross-divide where we can. And we end up with -4 for the quotient. Yes? In a minute. Any questions? All right, we are finished.